like to introduce, actually, before I introduce the next speaker, a quick administrative point. We do have an awesome videographer behind us. We are recording all of the talks and making the videos of the talks and the slides available after the summit. So with that, I'd like to introduce our next speaker, Bill Havanki, who's a solutions architect at Cloudera.
Thank you. Now that we're all locked in, we can start. All right, so thank you for sticking around after lunch. I'm sure you're all super excited and full of energy and ready to learn about testing. Yeah, I see some fist pumps in the back. All right. We're going to show them, right? It's a good thing you stayed on this side of the wall. All right, so we're going to have a tour of the in-depth amount of testing that Accumulo goes through before each release and in between as well. And I know this isn't necessarily the most exciting aspect of software development. I know most developers tend to want to run screaming when they hear that they have to do some testing. But what I want to do is twofold. One, I want to show that there is so much testing being done on Accumulo in order to make sure that it's robust, secure, works correctly, because your data is important and you have to make sure that it's in a system that's going to take care of it properly. And the other reason is to inspire you in your own software projects. You may not want to do everything that I'm going to show you, but you may show you some new angles on tests that you might want to add or give you some new ideas for your own project. So since this isn't the most exciting thing, I thought of I was in Disney World last month, and there's a lot of rides in the Magic Kingdom, and there's one ride that isn't the most exciting ride, but people like it anyway, you know, and it has its points. So in the spirit of that, when I'm my nice segue, when I'm going to click. Yes, so I'll be your skipper for this 3-week tour, or it'll feel like 3 weeks, of Accumulo's testing infrastructure. So what I'm going to do is start us from sort of the lowest level, smallest scale, unit tests, functional tests, and stuff like that, and move us up to tests that happen on a small cluster, and then ones that you really need a larger cluster to exercise. And that's going to be our path on this tour. So we'll start with the basic tests. And to start, I think the most fundamental level would be unit testing. So how many people here have unit tests on their own software? Come on, more hands. Yeah. How many of you are addicted to unit tests? How many of you freak out if you see a bar that isn't all green? Yeah, there you go. All right, good. So I counted, and we have about 1,000, just over 1,000 unit tests currently. And this is one of the places we're focusing on increasing our coverage to just make this tier a little bit more robust. We use JUnit most of the time. We have easy mock used for mocking objects. If anybody's not familiar with that, that's a way to take a Java object and replace it with a fake one that you then program with certain behaviors that you want to see under test. So you don't need an entire system running. In order to test some code, you just need to fake out enough of it so that the code that's under test will still run. And that way you can very easily stimulate a lot of different error conditions and a lot of different situations that you might not normally be able to get on say a real Accumulo cluster or whatever. So that can help you exercise a lot of new paths in your control flow. These can run under Jenkins. How many people have Jenkins or Hudson or Cruise Control or one of those other awesome things? Great. That, in case you're not familiar, Jenkins is a continuous integration tool. It can automatically run stuff for you. The stuff it runs most of the time is builds of your project. So you can have Jenkins automatically build your code every time there's a commit. And as soon as it breaks, it sends a nastygram to whoever broke it, which is usually fun. It can also do other things like run your unit tests for you. Those don't need to be run with a human at the helm. So it can run the tests, give you a nice report, generate your Maven site if you're using that. Otherwise, just give you HTML reports, and you can have that running all the time, and you can watch when your unit tests start to fail automatically without even having to remember to run the tests. And then you can find out more quickly when something's broken. Because as you know, the longer a bug sits, the more expensive and harder it is to fix. There's less focus here in Accumulo than in than in long-running tests, which I'm going to talk about. Those are where a lot of the system is stressed. But this is still a fundamental, important part of the testing. I was trying to think of some barrel jokes, but I never got around to it, so I'm just going to skip that. If I had, they would have tested your metal, that's for sure. Yeah, it's Jungle Cruise. Come on, you've been on the Jungle Cruise. You know what you should know? Well, anyway, I better not tell you what's coming. Anyway, functional testing is the next layer. This changed between at Accumulo 1.6. So I'll talk about it, what it was before 1.6. They were mostly implemented in Java. There were Python wrappers around it that would help you control it, get it started, do the reporting and all that. There were 72 or so of those. And though those were the next higher level, so it would be more of an integration test level where it would exercise different parts of Accumulo together. You did need HDFS and Zookeeper running in order for these to work. You did not have to have Accumulo running itself, though. But you did need some sort of, even a one-node cluster would have been fine to get these going. Usually when I ran these, I would actually have Accumulo installed in a cluster and just not running it and let the functional tests run, and it would spin up the code that it needed. You could do it from Maven. It was a little bit more of a trick to do that, but it was possible. And you can also run these under MapReduce. So if these tests are taking a long time and you want to get them done quickly, say you want to plug them into Jenkins so that you don't have to remember to run them all the time, and you don't want them to tie up a Jenkins worker for 2 hours. You could run these under MapReduce where it would send some of the tests to one node, some of the tests to another node, and run them in parallel. It's very cool. So before I move on, does anybody know what kind of snake that is in there? It starts with a P? No, it's a plastic snake. Plastic. Sorry. All right. So yeah, like I said, in 1.6, the functional tests were sort of redone. Now they're in pure Java, and we call them integration tests. They end in IT now, so they fold in with the Maven failsafe plugin. So it's a little more of a normal flow as far as integration tests go. They are run under Maven, and they can run under Jenkins again. I don't know if we can run them very well under MapReduce. I think that's something. No, we don't have that yet. We might. I don't know if we can get that back. Maybe not. Yeah, Sean's telling me yes. Okay, he's my co-pilot, by the way. These use something called the mini Accumulo cluster. So like I said, with the old ones, you needed a real HDFS and Zookeeper to run. This uses a component of Accumulo called the mini Accumulo cluster, which is making one Accumulo running on your local machine. So you get all of the Accumulo processes, and it uses a local HDFS, local MapReduce, and it spawns its own Zookeeper. So these really spin up a little tiny cluster and run each test, and they can share the cluster and all that, so you're not bringing up clusters all day. These run, when I run them on my MacBook, which they still run on a normal machine, they take me about 90 minutes or so to run, so I'd say between 1 and 2 hours to get through all of these. So they're a little more intense than the unit tests, which take around 8 minutes to run. So, but you're getting that higher level of testing. And if anybody's wondering about those natives, they're from the Brittany tribe. Yes, you can tell by the spears, yes. Next, I didn't want to move away from the basic tests without talking about static analysis tools. You may be using some of these. There are plenty of them. I'm just listing some of the ones that we normally use. Find bugs is probably my favorite tool in this area because it really has a low, is it high signal to noise ratio. It does a good job. It doesn't get you the wrong answers a lot. I find some of the other ones like check style to be really picky. This Find Bugs has got a very high quality output. PMD and is another one. CPD looks for code duplication. And I know a lot of the developers, a lot of the committers on Accumulo use Eclipse, and that gives you some warnings as well, which I don't get because I don't use Eclipse, so I don't care about them. And then Coverity, we started getting emails from them. They are a website that automatically is running their own analyses, which are pretty neat because they sort of work through different functional paths and try to find cases where like you may end up with a null pointer exception under some certain circumstance, and they lay it all out. So that is a newer sort of analysis that we're getting, but I know people are looking at it and filing bugs against it. So these are all important because these can catch bugs before they express themselves in production. So it's a nice way to make everything stronger on the basis of things. And in case you're wondering about that ape, he makes a really bad tester because he's always monkeying around. It's terrible, but it drives his manager bananas. Yeah. All right, so we're done with the basic tests, and now we'll move on to tests that you need a small cluster to run. And usually, by small, I'm saying 3, 5, 7, some small odd number of machines. You don't need to throw an entire server farm at these. These are very commonly run. And this is where we're getting to the ones where we more often run against Accumulo to find issues. So the first one I want to talk about is called continuous ingest. And this one is fundamentally pretty basic. It's got 2 phases. In the first phase, we run an ingester that pulls in some number of massive amount of rows. It could be 30 million or something like that. This is why you need a cluster bigger than just one machine. And the rows are brought in, and you run it for as long as you want to run it. You can let it go, you can give it a limit, or you can just keep it running. Sometimes we'll run it for 24 hours or 72 hours on a cluster. So you imagine this is pulling in data for 3 days. That's huge. That's just a giant amount of data. And then once you have that done, you run a verification job, which looks and makes sure that all the data has been written correctly. And that can take a while too. It takes on the order of a quarter to a half of the time of the ingest, roughly, to do the verification. So not only are you checking that the data got in, but that got in correctly. So this is a good way to really stress the system in a very basic, fundamental level, but starting to get at a bigger scale. All right. I have jokes about lions, but I'm going to skip them because I have more pride in my work than that. Then while we're running the ingest, we can run other processes because we want to complicate things. And this is where we start to get into the trend where we're not necessarily going to run all of our tests under optimal conditions. We want to make the system break if it's going to. We want to make it a hostile environment. So these are some of the other processes that we can run while we're running the ingest. One of them are called walkers. They have walkers and batch walkers. Fundamentally, the data that's getting written in there, each row is referring to a previous row, so they kind of form a chain, and so the walkers can walk along those chains. So that's sort of an integrity check, and it's also stressing the performance. Now, not only are you doing a massive amount of writes, but you're starting to do some reads in there as well. Scanners just do a basic reading as well. And then there's agitators, which if you've heard of Chaos Monkey, it's a Netflix started that, and I think a lot of other systems have similar processes. These are, while the ingest is running, it randomly kills different pieces of the system. It can kill Accumulo tablet servers, it can kill data nodes, it can kill name nodes. There's a few of the things it can take out. And the system should compensate and should just keep running. Once, say, a data node is killed, after a couple minutes, it's brought back up again, and then we can modulate the delay in that, so we can have things dying every 10 minutes or every 15 or every 30. We can change it around so we can make the conditions kind of hostile and make sure that ingest and all the scanners and all that just don't die on their own. So it's a very helpful. We can use the agitators not just for ingest, for other tests, which I'm going to get to, again, to keep the system under stress. And these monkeys, they're not bad. They make better testers than the apes because they really get into the swing of it. Yeah, that's not, yeah. Oh, I haven't been telling enough jokes. All right, it's joke time. See, it's after lunch. I got to make sure you guys are awake. There you go. Yeah, all right. Thank you. Yeah. Again, this is all really ripped off from Disney, so I don't take too much credit. All right. Goes along with continuous ingest, random walk. This is one of the more unique sorts of tests. I hadn't seen anything like this before. And when I first saw it, I figured, oh, well, there's a graph in an Accumulo table, and it's walking along the graph. But that's not what it does. It is a graph of test actions. So you can imagine it's a sort of a finite state machine of a set of operations that you can do on Accumulo. So, for example, there's one that just works on a table, and it writes some data, and then it reads some data, and then it runs a MapReduce job, and it deletes some data, creates tables, deletes tables, creates users, deletes users. But the actions are in a graph that makes sense. So when you start the test off, you may start creating tables, or you may start creating users. And then you're in a new state and may go off and do some writes. And then it might do some more writes, or the next time you run it, it might run a MapReduce job. So you get a randomized set of actions on Accumulo. I can sort of show you an example. Oh, this isn't my machine. I can't show you an example. I was going to show you a picture, but I didn't make a graph of one. So there are ones for, say, security actions, where you make users, grant them permissions, revoke permissions, and then test those permissions. And so those can all happen in a random ordering. Every time you run the test, it's different. So it really gets, hopefully, if you're lucky, you'll get into one of those weird situations where you discover something wrong that you weren't expecting. And it's because these random walk tests try to get you into those weird states that if you're running a system normally, you may hardly ever get into. But if you do, you want to make sure it's okay. There are 8 fundamental graphs, like one's based on security, one is based on bulk loading, one is based on just table access, and then there's other ones that combine them. So we usually run one that goes for 24 hours, and it just keeps picking new tests to run. So I'll run the security one, and then I'll run the conditional mutation one, and then I'll go back to the security one, and then I'll do a bulk one. And again, that's randomized as well. We usually run that for 24 hours before each release. You can limit these by the number of hops through that graph of actions, or you can limit it by runtime. So we can have it automatically stop after 24 hours or after 1 million hops or something like that. So you can configure all that to get the test situation the way you like it. One drawback with these is because they're random, you may not test every action in the graph. You may just luck out. 1 in 100 runs, you do hardly anything in that test, right? Because just randomly went right from the start state to the end state, the minimal path, maybe 2 basic actions. And that's not really exercising your system. So that's why we'll run them repeatedly. And we have those combining jobs that make sure we run at least 2 or 1 of each of them, just to make sure that we get a full sweep. But with these, the more you run them, the better. I have no jokes for that. It's not a funny picture. This one also isn't funny. This is an angry elephant, because this is a new test called the memory stress test. I have to thank Bill Slakem, who I don't know if he's here, Wilhelm von Cloud. He wrote this, and I got to play with it a lot. This is to test Accumulo's how it can deal with large keys or large values. And by large, I mean bigger than a megabyte. There are 2 parts to this test. They're 2 separate processes. One writes these rows with giant data, and another one reads these rows of giant data. And I usually run them for about an hour. I'll run 2 each, 2 readers, 2 writers on the same cluster. This was interesting because I was trying up to 100 megabyte keys. I don't know why you need a 100 megabyte key, but we tried it, and didn't like it at all. There's a lot of indexing with the keys that is used internally in Accumulo and in the R files that just makes those giant keys not work. But this is part of the testing also, is try to find the limits of what we can do. And we can actually do 10 megabyte keys. I found a lot of knobs to turn. If you were at Mike Drob's talk earlier about benchmarking, there are a lot of ways I could dial down different parts of the system to free up more memory and preserve it for handling these large keys and values. I was able to get 100 megabyte values to work without too much trouble. The keys, I had to go down to 10. So again, this is a newer part of our testing scheme, and it's very interesting to see what pieces of the system start to really feel the pain when you start to load on the large data values. So speaking of Accumulo and tests, here's some failure testing. So you know that in real world, you've got an unavoidable fact of life that you're going to have failures. These are just some of the failures that we test against when we're testing out the system before a release. We test not only pieces of Accumulo falling over, like the tablet server, but we test HDFS having trouble. And so some of this is related to the agitators that I was talking about with Chaos Monkey. We'll get this for free with some of the other tests. But we'll also have Zookeeper fall out and also take down entire nodes, just having them drop off the network and see what happens. So you got to be kind of brave when you're running these things. This is just a crash course on failure testing. I hope that's plain to everyone. This is just talking about upgrades. We do some testing. I'd say this is less formal than a lot of the other parts of testing we do. We want to make sure that if you've got a 1.4 cluster, when you go up to 1.5 or 1.6, that all your data is still readable. So we have some data compatibility tests. We want to make sure security rules are still going to be enforced the way you had them originally, so we have a test for that. Accumulo can already, as it's running, detect when it's been upgraded and upgrade your files, upgrade where your write-ahead logs are and all that sort of thing. So that's another thing that we observe and make sure that that's running and that your system's cohesive at the end. Because if you don't want to be stuck at an old version because you'll miss out on a lot of the new features and bug fixes that you could take advantage of. All right, now we're going to get to the big guys, the tests that we need bigger clusters for. And I'm talking 20, 40, 80 node clusters. So these don't get run that often. Scalability tests ship with Accumulo. There's really only one of them. It's a continuous ingest type test, but it's run on a massive scale. So you've got your 80 node cluster and you're loading so much data. And what you do when you're running these is watch your performance numbers. How long does it take for it to ingest so many rows? How long does it take to read? And you compare that with your past numbers. So this is something that you're going to test longitudinally. You want to make sure your new version doesn't have a 50% drop in write performance. And so scalability can really test that out. The crocodile there, he's not so bad as a tester versus that ape because he always has a smile on his face. He's good, but he tends to get snappy. So careful with him. Oh yeah, I do have another one. All right, so speaking of that, why did the elephant quit her testing job? There's not just one answer to this one. Yeah, that's the Disney one. All right, yeah, so the rest of them are mine. I don't know if these are any better. Yeah, I like the herd one. That's good. That one was too vague, I think. Yeah. And that's a Simpsons reference, I think. But okay, everybody's still awake. This is great. All right, benchmarks. Now, if you were at Mike Drob's talk, and if you weren't, you should go back in time and see it because it was good. He talked about YCSB, which is on my next slide, so you can go into the future and hear about that if you want. But I'm going to talk about these, which is just a set of 8 benchmark implementations that have shipped with Accumulo for a while. They're just basic sort of things, deal with a lot of small records, read and write them, or create and delete a bunch of tables. There's one that's basically terasort, so bringing in a terabyte worth of data. Again, these are useful to do longitudinally, compare across versions, and make sure you're not seeing a regression. But now I'll talk about it. Here, welcome to the future. All right. It's the Yahoo Cloud Serving Benchmark, or YCSB. This is a general benchmarking framework for databases, and there are bindings to allow the tests to run on whatever database platform you like. So Accumulo has a binding now, and so now we can take advantage of this, and this allows us to have even more robust benchmarks and also compare our performance against other databases. There's 2 phases in running YCSB. You load up a workload, which is a predefined set of data, a predefined structure of data, and then run your test against it. And it's once you have the binding ready, you just say load it and run it. And then it gives you a nice detailed report on all of the different performance characteristics. You can customize all sorts of things about the scope of those tests, the count of the records, how long the fields are, all of that sort of thing. And you can run multiple clients at a time. So we're kind of moving more towards, we like these, and the other benchmarks, well, they're still there, and we could use those, but this is really great, so we're focusing more on that. All right, we're getting close to returning to the summit. Yes, if you do leave any children behind, we will make them write unit tests. They think it's fun. All right, there's still more to do for testing. And I know the theme today is community, and if you're looking for a nice, easy way to contribute, writing a test is awesome. If you know Brooks' Law, you know that adding more developers gives you that n² increase in complexity of communication, but not with testers, because testers can kind of work independently. So this is a great way to contribute and not add to a lot of overhead in the project. And it's a great way to get familiar with the code base. That's basically what I did when I started working on this back in September. We need more coverage for our unit and integration tests. We're at around 30% right now, which I wish were higher. Paying more attention to the static analysis tests, find bugs and PMD, they tell us all these issues that we should look at. And just being able to look at those and say, yep, 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 nope, yep, and fixing those is great. It just helps us a lot. Chasing down performance regressions. We want to make sure that Accumulo, as it goes on, keeps getting better, faster, stronger. And if it's not, having somebody pay attention to why is that not working, especially if you have a vested interest in it. If it's causing you some problems and you're motivated, that's great. We can always use help with performance testing. And basically making the tests easier to run. The more people that run them, the more sure we can be that the system is in good shape. And so you can run unit tests yourself. You can run functional tests yourself. Just having more people running that stuff and paying attention, just keeping an eye on everything is great. Well, there's my thanks to Sean and Mike Drob there for reviewing these slides, and thanks to all the community and the committers for helping me out. I haven't been working on Accumulo for a year yet, so I'm still learning. It's a lot of stuff going on. I want to thank Lauren Javier, who was like most of the jungle picture picks. He's crazy. And you guys, thanks for staying awake. Make sure you please visit our booth. That's Sam. He's our head recruiter. He keeps complaining our candidate pool's been shrinking, but I don't know. All right, and now for the most dangerous part of your journey, the rush to the bathrooms after lunch. So thank you, and please exit the boat. Have a great day. I suppose if anybody has any questions, I don't know how much time we have left, but does anyone have any questions? It was a perfect tour. Wow. Oh.
So with the random walk testing, does it log what the walk was? So say you do find an issue, can you go back and rerun that same random traversal?
So the question is, does the random walk, when it runs, does it log where it went so that if you hit a problem, you can reproduce it? And it doesn't well enough. And there's actually a JIRA for that. To do that, because we want to be able, when you're random, you might hit this weird case, and if you don't have enough information to figure out what happened, you can't find it again, and you need to reproduce a bug in order to fix it. So there's a JIRA to do that. The tests usually do some logging, so even now you can kind of figure out what was going on, but it isn't clear enough. So that's somewhere we need to improve.
Do you use an existing framework for random walks, or did you write your own?
It's our own.
Okay.
I didn't write it, so I can't take credit for it. But it's our own. It uses XML to lay out the graph with weights for the different edges, and then there's just some simple Java code that just hops along the graph and then calls. Each node is associated with a Java class that's just going to do whatever it's supposed to do. So it's pretty basic, but it's pretty powerful. Yeah. Question is, how often do we run those large cluster tests? It's like whenever we can get the hardware. Yeah. We, at least at Cloudera, we do get access to a 20, 40, and 80 node cluster, but there's a lot of contention for those, because everybody wants to do some massive, large-scale tests. So we put in for time before a release or before we were going to deliver something, to make sure we have at least a chance to do it. Should it be done more? Yeah, sure, it would be great. But that's why we also have the lower level tests. Maybe you don't need a giant cluster to run. It can help you out. So the question is, do we do data integrity and reliability testing? Yeah. Some things like the continuous ingest that actually has verification steps, it's expecting that the data is of a certain form, and if it doesn't find it, it's going to fail the test. I don't know of anything that does like ruining the metadata, for example, and seeing how it can. We might. Do we have some testing for that? So if you didn't hear that, Sean helped me out and said that we do actually have integration tests that mess up the metadata table so that we can recover from it, because prior to that we didn't. So, all right, that's great. Thank you. Anybody else? Okay. All right, thanks a lot. I'll be around if you have any more questions.